Hello everyone, my name is Fanindra Charakuri and I'm a student at Rutgers University, and I'm here to talk to you today about the language R for statistical computing. This presentation is just to give a short introduction to R programming in the context of data analytics. So here's a look at the scope of this particular presentation. This presentation doesn't go too deep into teaching R, but rather gives you an overview of what R is used for, how is it useful for data science, how you can install R on your computer, and some good resources for learning R more efficiently. And I will demonstrate how to calculate a z-score and plot it in R as a demonstration of using R for descriptive statistics. And lastly, a brief discussion on the limitations of R and some alternative solutions in those cases. So let's get started. So what is R and why is it useful? Well, R is a scripting language available for Windows, Mac, and Linux. Its main use is for statistical computing, data manipulation, and data analysis. But it also serves as a general purpose programming language, so you can take these data analysis tasks that you might perform manually and actually automate them. So in the case of large data sets, you don't want to be doing analysis by hand because that would take a really long time. So R is really helpful for automating all those tasks and processing large data sets in a short amount of time. As a general purpose programming language, R also allows you to create new functions that can extend the existing features available in R. So since it's an open source language, many users have created their own functions that they've added to the large database of R's libraries for everyone to use. As a programming language, it also incorporates object-oriented philosophies and functional programming philosophies. It's a very powerful visualization tool for large data sets. One particular R package that's really useful for this is called ggplot, which I won't go into, but it's a very powerful visualization tool for plotting statistical concepts. So where is R used currently? Well, R is really used in a wide variety of industries today. Financial companies, government offices, healthcare, scientific research, you name it. Wherever there is data present in the industry, R is probably being used there to cope with the large amounts of data coming in from all of the sensors and embedded systems and just general data flow that is the norm for today's society. Some really well-known companies that use R for predictive analytics. Facebook uses R to analyze their huge user base, the status updates of their huge user base. They analyze these status updates and then they figure out what the general consensus is for users on certain trending topics, such as the elections that are going on right now, or maybe user preferences for certain consumer goods, and through that they can figure out how to better target ads towards certain users. Bank of America uses R for financial reporting and market health. Uber uses R for statistical analysis that leads to predicting what driver routes may be better in their app and therefore allow for the most efficient route to be taken for every Uber driver. Google uses R for a wide variety of things. They use it for return on investment calculations for their extensive online advertising. They use it to analyze which TV programs are effective and which aren't, and display information on those TV shows accordingly. They use they use R for economic predictions. The National Weather Service uses the powerful visualization of R to generate graphics for flood forecasting and other weather phenomenon. The FDA uses R for like daily for research data, and many FDA scientists have actually written R packages themselves and contributed to R's library for other users. So let's talk about installing R on your system if you want to get started with R and get it up and running. Here I provide a link to R's website, rproject.org. So that's where you can learn more about R, and then you can also find download links for R. I provided one mirror here from UC Berkeley. So if you look over here, there's 3 download links for Linux, Mac, and Windows. So based on your operating system, you would choose the according link, download, and follow the instructions for the install package. And it's relatively simple to set up. So after that, after you have installed R and open it up, the next thing you might want to do is install R packages. So in order to start doing that, you want to select the Packages tab and then go to Install Packages, which will lead you to this pop-up where they have numerous mirrors for different countries. So you want to scroll down to USA because I'm assuming that you're located in the USA if you're watching this video, and then select the mirror that is closest to your physical location for optimal download speeds. So after that, you'll see another window pop up, Packages, listing all the packages available in R, and there are a lot of packages. So choose a package that you'd like to load. For example, ggplot. It's listed alphabetically, so you want to scroll down to G and find it there, and then click OK. And R will load the package for you, but in order to actually use your package, you want to go back to the Packages tab and then click Load Package. So again, this presentation doesn't go too deep into teaching the programming of R itself, but here are some good resources in order to do that. Highly recommend the textbook, The Art of R Programming. It assumes no prior knowledge of using R or even programming in general, and teaches it to you from scratch, step by step. With pictures included, so it's a great resource. Another great resource that is free to use is Marin Stats Lectures YouTube channel. The playlist in particular you want to look at is R Programming Tutorials, and I provided the link right here, direct link to the playlist. He has R videos ranging from, again, the introduction to R itself, assuming no prior knowledge, all the way up to advanced descriptive statistical concepts like chi-square. And lastly, on lynda.com, as an ITI student, there are some great video tutorials available to learn R, and those are highly recommended as well. So now I'm going to demonstrate how to calculate the z-score and plot it in R. This is going to be a quick demonstration, and I'm not going to go into explaining the programming concepts of it, but I'd just like to demonstrate just one of the few powerful features of R for everyone to see. So now I'm going to go over to the R console. So this is what the R console looks like when you start it up. And so let's say we want to calculate the z-score, which stands for the standard normal distribution. So we want to calculate the z-score of 1 or higher. So we do that by using the p-norm function. So we'll set the z value to 1, the mean to 0, the standard deviation to 1, and the lower tail value to false. And this is to have an upper tail probability. And then click enter. So as you can see, the area above a z-score of 1 is about 0.158, or approximately 16%. So let's say maybe we want to find the quartiles or percentiles for a normal random variable. So let's try to find the first quartile. By the way, these pound symbols are just comments. So in programming, comments are just for the user to make notes. It's not an actual command that R interprets. So to find the first quartile, we'd use the qnorm function, and here we'd set a p-value. I'm just making up values here as an example. Let's say 0.25 for the first quartile, 25%. We'll set a mean of 75, standard deviation of 5, and a lower tail equal to t, which stands for true. And then click enter. So the approximate value for the first quartile here is 71.6. Now you might also want to find and plot the probability density function. So in order to do that, we use the dnorm function. But first, the first thing we want to do is create a sequence of x values from for a certain range for the above specs, a mean of 75, standard deviation of 5. So what we'll do is we will create a sequence of values from, I'll just choose a lower end of 55 to upper end of 95, and then we'll do it in increments of 0.25. Now, to make this easier so that you don't have to keep track of all this information again, I'm explaining this in a very generic way, but you want to place this in an object. So the assignment operator in R is a dash and a less than equals sign, greater than sign. So that's the assignment operator, and we're going to put in an object called x, and then we're going to save it by hitting enter. And then we can confirm that R has indeed saved this range in x by just typing x and clicking enter, and the values are displayed right there. So now we'll use the dnorm function to create a plot to find the probability density function and plot it. So we'll use the dnorm function and put x in there, mean of 75 in line with our previous example, and a standard deviation of 5. So we want to save this in another object to be able to plot it, so we'll call that dense, D-E-N-S. Save it like that. And now to create a plot, we use the plot function. So we want to plot x and dense. And over here you can see the resulting plot. So now if we want, we might want to have we might have all the points in this plot attached using a line, and we can do that by just adding on to our last command. And an easy way in R to bring up your previous commands is just to type the up arrow on the console, the R console. So just like that, and I'm bringing up my last command and adding on to it type equals L. Click that, and there we can see the line. So now you might want to add more details to your plot, such as description on the x-axis and the y-axis. Again, going to bring my previous command up and just add on to it using main. So that's for the x-axis, so I'm going to call it x normal mean 75, standard deviation 5, slab equals x, y lab equals probability density equals 1. As you can see, the titles appear on the plot. So that was just a brief demonstration of one of R's features, calculating a z-score and being able to plot the normal distribution accordingly. Now R can do this in an automated fashion, and you can save your workspace upon exiting. Back to the presentation. So let's talk about some limitations of R and what the alternative solutions there are available. So R is a scripting language, therefore it's not a substitute for a compiled language like Java or C, which Java and C have many more features available to them to create powerful applications, and R simply is not a viable choice for that. It was created with the intent to perform statistical computing, data manipulation, data analysis, and therefore it's meant to just create automated scripts. Although you can integrate R and C together to create some powerful data applications, but I won't go into that. So in the case that you want to create more robust applications, you might want to use something like Python. Python is a full-fledged is a scripting language that is more programming based than computing language. MATLAB is another good alternative that incorporates more fields of math rather than just statistics. SAS and SPS are also great and widely used statistical packages for statistical computing, although they require less programming knowledge than R might. So that's it for this presentation, and here's just a quick summary of what we covered. R is a really powerful tool to be able to manipulate data, analyze it, and then visualize it in some really great ways. It's meant for statistical computing, and R is used in almost every industry out there today that is dealing with data. Um, whether it's government, healthcare, finance, engineering, um, scientific research, and it's used by great companies like Facebook, Google, Uber, National Weather Service, Bank of America, Bloomberg. Although it's not really a substitute for a compiled language like Java and C, R scripts are really powerful for taking statistical concepts like descriptive statistics, z-score, chi-square, and relating it to these large data sets and providing visuals. R is available for Windows, Mac, and Linux and is completely free to use, so it's a great alternative to packages like SAS and SPSS or MATLAB where you have to pay for a license. And there's a lot of great resources out there to learn R and become an R programmer yourself. The book that I mentioned is great, The Art of R Programming. Um, the YouTube channel and the Linda tutorials. Anyone watching this presentation should definitely check all three of those out to be able to learn R better. Thank you for listening to this presentation, and I hope that I've given you a detailed overview of how R is useful for data science. Thank you.